Have you ever really stopped to think about what separates a regular old pane of glass from one that can stop a bullet? I mean, it's not just about making it thicker, right? Well, today we're going to dive deep into the hidden science, the atomic level engineering that turns one of the most fragile materials we know into a literal life-saving shield.
Okay, let's get right into it. And we're not starting where you'd probably expect, like in some high-tech lab. Nope. Our story actually begins at a crime scene with a forensic puzzle that had investigators scratching their heads.
So here's the situation. A homicide victim was shot through their car's side window, but the autopsy turned up something really weird. Strange, deep cuts around the entry wound. Now, the bullet itself was found totally intact, so it hadn't broken apart. Something else had acted like a weapon.
And that is the central question, isn't it? We all think of glass shattering into those little, relatively harmless cubes. So how in the world does that become a projectile that can do this kind of damage? Well, to figure that out, we've got to unlock a pretty fundamental secret about glass itself.
You see, glass is a material of just complete extremes. It's both incredibly strong and, at the exact same time, unbelievably weak. And the key to understanding that whole paradox is really understanding its greatest vulnerability.
So get this. If you squeeze glass, put it under compression, it's remarkably tough. But the second you try to pull it apart, even a tiny bit, it just fails. That's because every single piece of glass, no matter how perfect it looks, is covered in microscopic cracks. And when you apply tension, those tiny cracks get pulled open, and a fracture can just race across the whole surface in an instant.
And look, even the official industry standard says it right there. There is just no such thing as truly unbreakable glass. It can all break. But, and this is a big but, engineers found a brilliant way to fight back by basically building a suit of invisible armor right into the surface of the glass. So that leads us to the crucial question. If you can't get rid of those tiny microscopic cracks, how do you stop them from spreading? Well, the answer is this amazing process called chemical strengthening, and it literally rewrites the rules of the material at an atomic level.
Now, I know ion exchange sounds super complicated, but the core idea is actually beautiful in its simplicity. You're basically just swapping out some of the atoms on the surface of the glass for bigger ones. That's it.
Okay, so take a look here. On the left, that's your standard glass full of these smaller sodium ions. But then on the right, you see what happens after this special treatment. These larger potassium ions have literally forced their way into the spots that the sodium ions left behind. The whole process is kind of like trying to stuff an oversized suitcase into a small overhead bin on an airplane. You dunk the glass into a bath of molten potassium salt. The smaller sodium ions naturally leave the glass, and these bigger potassium ions rush in to fill those empty spots. This crowding effect, this stuffing, puts the entire surface of the glass into a state of massive compression.
And here is the result. Just look at that stress profile on the graph. The surface is under so much compression that it physically squeezes those microcracks shut, stopping them from ever getting a chance to open. It creates this powerful protective layer, which is balanced out by tension deeper inside the glass. This exact profile, that's the unique signature of chemically strengthened glass.
But wait, this super strong glass, it's just one part of the puzzle. To get to what we think of as bulletproof glass, the kind that was in that car window, you actually need to build a really clever composite. Yep, it's basically a glass sandwich. You take two layers of this awesome strengthened glass, and you bond them together with a flexible plastic inner layer. This plastic, called PVB, is the real secret weapon. It does two critical things. First, it absorbs and spreads out the bullet's impact energy over a much bigger area. And second, if the glass does crack, it holds all those dangerous shards together, preventing them from flying everywhere. And this brings us right back to our forensic mystery. See, when a bullet hits this laminated glass, it doesn't just shatter. It punches out a whole chunk of that plastic glass sandwich. And this compounded fragment, as they call it, stays together because of that plastic layer. And what's really incredible is that forensic scientists discovered that different kinds of bullets, like a deforming round versus a full metal jacket, create completely unique and identifiable fracture patterns. And these fragments are not harmless at all. They get ejected from the window with incredible force. I mean, you can see from the testing, they can penetrate over 16 millimeters into ballistic gelatin, which is designed to simulate human tissue. This wounding potential is exactly what caused those deep abrasions in our case from the beginning. The glass itself became a secondary projectile. Mystery solved.
Now, you might be thinking, this is all just some exotic tech for armored cars and high-security buildings. But the truth is, this incredible science is probably in the palm of your hand right now.
This process of chemical strengthening is used in tons of high-performance applications you might not think of. It's in the cockpit windows of airplanes that have to deal with insane pressure changes and impacts. It's even used for the glass platter spinning around inside computer hard drives.
And check this out. Here is a truly life-saving example. The tiny glass cartridge inside an EpiPen, that has to be chemically strengthened. I mean, think about it. It has to withstand the massive pressure from that auto-injector spring without shattering, making sure that a life-saving dose of medicine gets delivered safely every single time. It's amazing.
And here it is, the most common application of all. That durable, scratch-resistant screen on your smartphone, it gets its toughness from the exact same ion exchange process. The very same science that stops bullets is what helps your phone survive the daily bumps and drops of modern life. It really just goes to show you, sometimes the most incredible feats of engineering aren't in giant skyscrapers or spaceships, but they're hidden in plain sight, in the objects we use every single day. So the next time you pick up your phone or look through a window, maybe you'll wonder, what other extraordinary secrets are hiding right in front of us?